Dear friends, Mass Aspirants is a community of mathematics students, research scholars, and teachers initiated by myself in 2017, and we used to conduct several online problem-solving sessions and test series to help the students who prepare for different national-level competitive examinations like IIT JAM, CSER NET, GATE, NBHM, etc. As a part of that series, today we have Mr. Rajendra Rajpurohit with us to handle a session on IIT JAM examination. He will discuss with you his insights about the IIT JAM examination and will describe problem-solving strategies through the problems in the previous year 2021 of IIT JAM examination. Mr. Rajendra is currently pursuing PhD at IIT Roorkee, and he is from Rajasthan. He qualified CSIR NET, JRF, GATE examination many times, and he guided many students for these examinations. I'm sure that today's session will be really helpful to all of you. I would like to thank Mr. Rajendra for accepting our invitation and joining with us. This is actually the second time Rajendra is handling a session in our platform. I welcome everyone to this program. Welcome, Rajendra.
Thank you, sir, for the introduction, and very welcome all of you to this session. So today's goal is simple. We'll do some analysis of IIT JAM exam, particular specifically for mathematics. And then I'll do some questions, and we'll try to, using those questions, we'll try to catch some concepts. So I'll go ahead, sir.
Sure.
Yeah. All right. Perfect. Great. All right then. Good evening, everyone, and very welcome, all of you. So in the first part of this session, we are going to discuss about, let me just give you the complete introduction about this session. So in this session, our topics are, we'll talk about topic-wise marks quota, that which subject reserve, how many marks are there for IIT JAM exam, cutoffs, what were the previous year's cutoffs, number of seats, how many seats are there in total, and again admissions, and then in the final part we'll go for problems from JAM 2021 question paper. Okay, so that is all aligned for today. So everyone, if you guys can text me in the text section, I think you know how to do that. So you can just text me if you have any question. You can unmute yourself and you can ask any query if you have. Okay, so let's just begin for today. Okay, so first of all, if I go for topic wise marks reservation in this exam, so the analysis again goes at the top with the most marks, 21%. That means 21 marks out of 100. And also that when we are teaching, or I am teaching in general, then we consider calculus of one variable also in the real analysis, and calculus of two variable also mostly in real analysis. So like this analysis part is huge, like you can say almost 50% reservation in your single exam. Then we have algebra for 14 marks, we have vector calculus for 12 marks, we have differential equation, ordinary differential equation for 11 marks, and abstract, specifically group theory only for you for 10 marks. So that's total 100 marks for you in this exam. There was integral calculus too, but they somewhat removed it in the last 2 or 3 years as I am aware of. So yeah, so maximum marks is in analysis part. And if we look for the cutoffs for the last 5 years, then these are the cutoffs in the respective subjects. Like I'll go for mathematics, like 24.5 marks, and then we have 22.9 marks, and then we have 24.6. Again, this is for 21, that was for 22, and then this was for the very last year. And if I go for 2020, that was 33.6. The paper was very easy comparatively. And if I go for one more past year, then we see here around 23 marks. So again, so the cutoff, if you look at the marks reservation here, then I think that this real analysis alone is doing the job. If you go for real analysis and function of one variable, they are exceeding cutoff every time, but they looks good in the numbers. questions are really good from that area. So you need to put a lot of efforts, and even some good conceptual questions have been asked in these subjects. Algebra is also getting interesting year by year. If I look at the previous year previous year's question paper from last 2 or 3 years, algebra is getting better. Though it has only 10 marks in your exam, but questions are really good. Linear algebra is a scoring subject here as well. If you go through a little bit theoretical concepts, then you can get pretty much good marks in linear algebra as well. And level of the questions, if I see, then they are somewhat tricky, and some are really conceptually strong. So it's a good exam if you look at the level of the exam. Okay, now we talk about the next part, which were what is the, what are the number of seats and admissions and all. So I calculated it today, and there are almost around 720 or 721 seats in the IITs alone. Okay, 720 or 21 to be exact. If I'm almost sure, it's 720. You can approximate. And there are 21 IITs, and you have 721 seats there. Some IITs just have 20 seats, and some have 60, or even IIT Delhi have 60 or 68 or something. That's maximum number of seats, I think. Okay, now if you look for the cutoff marks, and if you think that if you qualify and then you will get into the IIT, then that's not the reality. The cutoff marks is like just you are qualifying the exam, and you don't even get into some NIT if you just qualify. So you need to look for a higher score as well. That means rank. So what you can see on the board is 721. So if you are in 721 rank, then you will get into IIT. Again, that's not correct. There is the reservation scheme too. So if you are in the general category, then you need to get under 500 at least to get into an IIT. And I'll speak for general only. And if you get more than 500, then you will end up with some NITs. If you are up to 1000 or 1100, then you can get decent NIT at least. So the first rankers goes to IITs, and then NITs, and then we have many more institutes like Thapar, and so many are there where you can take admission and continue with your masters. So yeah, that was all about the information that I had to share with you. Now we'll go for the the question papers and practice. But if till now you have any question, guys, you can ask so far. So now if you have any question, anyone? Okay, now if you look for the strategy, if I am going for this exam, then I'll not leave analysis. Okay, real analysis is there, 21, and I'll go for this 39, and this, that's what 53%. Okay, so like if you do analysis, if you do good in analysis, then you are done with your qualification is done. Now you can do other subjects for to get better rank. So yeah, this subject you cannot leave these topics first, and second, and this one. Okay, so these three topics are like, they are difficult, they are conceptually strong, but they are the scoring ones. Linear algebra is there to actually score. If you go through it once, okay through the theory, you can correct some questions. And algebra is getting good, as I said. OD is easy because you all of you go through the ordinary differential equation in your graduation, and it's formula based subject. So again, easy. Same for the vector calculus, it's formula based subject, again easy. So they are somewhat, this applied part is somewhat easy to score because these two because most of them are formula based. So yeah, now I'll start some questions, and so we are going to make it a little bit interactive, because if just I am speaking, then it's not a really interesting story. So I'm doing the 2021 question paper of IIT JAM, and I have picked some really good conceptual questions and mixed up some easy questions as well for you and for me too. So we'll do mixed up problems today, and I'll try to explain it to you in a manner where you are intermediate, because if we go for one by one concept, then I think like we'll have to go for the whole course. Okay, let's just start for today. This is the kind of question which I found in this exam, like one of the best question according to me. And so I would like you guys to try and answer. If you can answer, you can unmute yourself and answer, or you can answer in the comment section here only. Anyone would like to answer this? So you have been given a continuous function which is non-constant, that is also the information, and the composition of the function with itself is again the same function. And then you are collecting some points in a set which are actually fixed point for f. And what can you claim about this set? It's a single correct question. Anyone would like to answer this?
Interval.
It should be interval. Okay. Anyone else wants to try? Okay, can you explain who said interval? Like, how did you arrive to that answer somehow?
It looks like identity function itself.
It looks like an identity map. Okay. So that's again a guess that it looks like an identity map. But can we have any other function than identity map? That's again a great question, and one can try for that. The thing is, let me just solve it, option by option. Okay. So for option, yes.
Sir, I think it's option D.
It need not to be an interval. That's what you are saying.
Yes, sir.
Okay. All right. Now to do this question, let's start with option C. When the question is single correct, then you try to discard some option and then you look for the proof and something. Okay. So if I start with C, it says that the set is empty. Now, if you have a result, or if you don't remember it, I'm going to write it here, that if you have f, a function from AB, I'll write it more precise and more general form of the result, AB to CD. Okay, and CD is contained in AB. And you have also been given that the function is continuous. Then f has at least one fixed point. Now, what is fixed point? The solution of the equation f of x equal to x. Okay. And in this case, we have A, B, and C, D same, 0, 1 to 0, 1, continuous as well. So this function will have at least one fixed point. Okay. So this set EF will be non-empty for sure. Right. This simply implies that EF is non-empty. So this C we can discard. Okay. Now we go for other options. For option A, look at this. Okay. I have been given that f is continuous. I define a new function. Define h of x, a new function that is equal to f of x minus x. Okay. Now your set EF is equal to the set of zeros of h. Yes, wherever h is 0, wherever your h is 0, those are the member of EF, right? Because f of x equal to x at those x, right? And also this f is continuous and x is also continuous. So both of them are continuous function. And if you take difference of two continuous function, that is again continuous. Okay. So we have h is from 0, 1 to 0, 1, continuous. Okay. And this EF is actually, the set EF is precisely h inverse of 0. right? We take 0 from here. That means the fixed points or the elements of the EF are actually solution of H of X equal to 0, right? So we take H inverse 0, that will give us the whole set EF. Now we have the result that inverse image of a closed set is always closed under continuous function. Yes, inverse image of a closed set is closed. If you don't know that, this singleton 0 is a closed set. So whatever inverse image of this set is, that is going to be closed, right? So EF is actually an inverse image of a closed set. Can be, it can be proved that it is an inverse image of closed set. So it's a closed set. Okay, closed set. So by this logic, I can actually discard option A. It's saying it's neither open nor closed, but the set is actually closed. So my option, this is for option A. So this is for option C, and this is for option A. Now I'll go for the next option. Now the other two options are actually somewhat contradictory to each other. So we have to go for one. And how do we do that? Let's just try to select one or discard one. Now I'll go for the so now I have not used this condition that FOF equal to F. We haven't used this condition at all, right? This all we did just using the property of continuous function. Let's move to the next one. We have been given that F of X. If I put X, okay, that's again F of X. Okay, and where my F is actually a function from 0, 1 to 0, 1. Okay, forgive me for the handwriting. Okay, is it understandable? It's fine now. Anyone?
Yes, it's fine.
Yes, sir.
Yeah. Okay. Great. Okay. All right. Yeah, I can see your text as well. You can just put the text here. Okay. So F of X is actually F of X is this belongs to the range of the function, right? This is an element of range of function, range of F, right? Now if I take any element from the range, now if I take Y belongs to this, let's call this set S. Y belongs to S. This implies that Y is actually F of X for some X, right? Okay, so if I replace this here, let's see what I get. F of X is equal to F of X. This implies that F of this is Y is equal to Y. This implies that Y belongs to EF. Is it fine? Because all those elements which are self-mapped or fixed point, they goes to EF. Okay, and this F of Y is actually Y. What I can get from here is that if you pick any element from the range, that is getting fixed, right? If I take any F of X, under F, image of this F of X is again F of X only. That means these F of X type element, that means any element from the range is actually a fixed point or is actually an element of this set EF, and vice versa, because EF is always in the range. Its image we are collecting, that cannot go outside of 0, 1. Okay, so overall what I get is, in conclusion, I get that this EF is actually the range of the function. Okay, now you tell me, if you have a continuous function and you have close interval 0, 1, the image of close interval 0, 1 will be an interval or not?
Will be a closed interval.
Will be a closed and bounded compact set, right? So now I use the identity theorem, so-called identity theorem, or the result for continuous function, that under continuous function, image of interval is an interval. Okay, you can write one extra result, that if you have a continuous function, image of interval AB is actually going to be some CD, compact. Compactness is preserved under continuous map. That will be then another, that will be another theorem. So now the range of F is actually image of an interval. So that's going to be again an interval. So the set is interval. Moreover, it's a closed interval. Moreover, it's a compact set, closed and bounded. Okay. So now we get the conclusion that this is a true option and this is false. Okay. If you have any question in any option. Okay. Yeah. So that was like a really good question. Let's move to the next one. I'll take another question again from the analysis, and that is again one of the great question I found.
Sir,
Yes,
excuse
yes.
me, sir, I think I have a counter. Please tell me it is correct or not. If it's equal to 1 minus x,
X equal to 1 minus x.
if it's equal to 1 minus x, sir.
Okay. Okay. So now you are getting f of f equal to again f, right?
Yes,
Or no?
yes,
No,
yes,
f of f equal to f, or you are getting identity map.
Oh, sorry, sir. I actually take that if as identity. Sorry, sir. Sorry, sir.
Yeah. So I mean, since the range is also positive, otherwise for f of f equal to f, you have identity function, and you also have minus of the identity function, negative identity function. That can also be used as a counter. Okay, but in this case we have 0, 1 to 0, 1, so the range doesn't contain negatives, so you cannot use the negative of the identity function. So whether it is an identity function or not, that's again a great question, and I have not.
It will be identity in the range, but outside range it need not be. You can just map the outside part to the endpoints. So
No, what I'm saying is that how can we say for the sure that it will be the identity map?
no, it will be identity in the range.
Yes, that is for sure.
For example,
every element is fixed, yes, from the range. Yes, that is.
Yeah, let's consider the function. Let's say f of x equal to x in half to 1,
Yes,
and from 0 to half, let's map it to half. Half
Okay.
to 1, you are mapping it to half.
Yes. Something like this you are saying.
No.
Okay.
So half to 1, it is constant.
Oh, like
constant.
this.
Yeah.
Okay.
No, not like that.
The opposite
it
way.
should be up. It should be from half.
Okay.
You start from half.
Okay.
Constant half from 0 to half.
Constant. This part is constant. Which
the
part?
function value is half from 0 to half.
Okay. This.
Now you go identity.
Okay. Something like this. Okay.
Yeah, exactly.
Yeah. I think that will work as a counter. Yes. Yeah, pretty much. Good. Very good. So we have counter. Now we have counter. Okay. So that means the only we had to go through is this whole theory. That was the only solution in that case, because it is not identity map. We have counter for that. So you had to think this in the exam. Okay. So that was the question. So every element in the range is a fixed point. That's it. So whatever in the range, that is a fixed point. Okay, let's move to the next one. This was also it's NAT type, but it was again a good question, that you have to consider functions from R to R and function from R to R, which is a continuous function, and then you have given the properties that for any x belongs to R, for any x belongs to R, f of x belongs to Q if and only if f of x plus 1 belongs to Q complement. This is the condition. And given that the function is continuous, so what do we do with this? Because that's how you start solving a problem. You have to look at the given information and you have to use it, right? So continuity is there, and then there is this condition. So we have to use these both conditions and try to figure out that how many such functions we can have. We can have any or not. That is again a question. Okay. So that was the question. If any of you would like to answer this question. That f of x is rational if and only if f of x plus 1 is irrational and you have been given that the function is continuous. Okay.
Zero, I guess.
Yeah, there will be no functions. Yeah, there will be no such function. And how do we prove it? That is another question. Okay. If anyone would like to give some insight?
So we can consider another function hx
Yes,
equal
exactly.
to fx minus fx plus 1.
Yes, and then we can use that interval property again.
Yes.
Yes. Okay. So we have we define a new function. Define h of x equal to f of x minus f of x plus 1. Then as f is continuous, we have h as a difference of two continuous function, again a continuous function. So we have h from R to R continuous. Okay. Now f of x is in rational, let's say, or otherwise without losing the generalization, we fix one f of x to be rational. Then f of x plus 1 will be an irrational, or vice versa. If f of this is rational, then this is irrational, and if this is irrational, then that is rational. We can use that fact. Okay. So this one of them is rational. This is a rational number. Okay. So f of x belongs to rational, and f of x plus 1 belongs to irrational. So the difference will be rational or irrational. I have one rational number. I have one irrational number. The difference will be rational or irrational. Anyone?
Irrational.
It will always be irrational, right? So this belongs to Q complement. So we have h from R to R continuous, and we have h of R is contained in Q complement, because h of x is always irrational for any x, right? Now we use this property again, which I wrote here, that under continuous function, image of an interval is interval. So what we need here is that first condition is we are getting from the given condition on the function, and the other property that h as a continuous function should follow, that h of R should be an interval. Second. Okay, these two property it should follow. So that means it should be a subset of irrational number, and it should be an interval. Now, do you know any subset of irrational which is an interval? Yes, only singletons, right? We can write something like this, like pi and pi. That's an interval referred as trivial interval. That's a singleton set, right? This one, or any irrational number you can write. Those are the only possible, intervals you can have in irrationals. Otherwise, between any two rationals are missing. So that cannot become an interval now. So these two implies that h is a constant function. Okay, so you get that your function h should be a constant function and a fixed irrational. Now if you go back to f and compare with this, you cannot find any such f, because it is rational and irrational both. Okay, so you cannot find a single such function which behaves like this.
Sorry, I didn't understand the last.
Okay. So we get that h of x is equal to, let's say, some alpha for all x belongs to R. Fine. Yes. So I get h of x equal to alpha for all x belongs to R, and that alpha also an irrational number. Okay. And this is actually f of x minus f of x plus 1 is equal to alpha. Now I want you to think about this and this at the same time. Can you get a non-constant function which is continuous and behave like this?
That's the question, right?
No, you had to arrive here. Okay, because because now we are getting that the difference is constant. Before that, we didn't know that actually the difference is constant. Getting me? The difference.
Okay. So how does that help us say that it's empty?
Yeah. That I'm arriving on. Okay. All right. So we have that the range should be irrational. Okay, that is fine. And we have that it should be an interval. So that pretty much only conclude to a constant function. Yes, that conclude to a constant function. And we have a continuous function, and it's a constant. The difference of f of x and f of x plus 1 is a constant map. Okay, just give me a second. F of x minus f of x plus 1, I get a constant number alpha. Okay, fixed constant for all x. Okay, so now I can think something graphically, can I?
I mean,
okay.
if you just want this condition, straight lines will work. But the point is fx in q and fx plus 1 in r minus q.
Yes, exactly. So this is yeah, that we need to consider, obviously. This is q, and this is in q complement. Okay, and we are getting a constant number every time. Okay. No, I did it, but it just slipped out of my head. Okay. It should be a constant every time. Okay. I have. Okay, it's a constant number, which is always in.
Okay. How about we think about it this way? Let's say we only have countably many rationals, but uncountably many irrationals, right?
We have
countably many rationals, but uncountably many irrationals.
Okay.
So we know that it's not a constant function because you have two different values, one rational and one irrational at least, if it exists.
It cannot be a constant function because you know.
It cannot be constant. That is true. So so we are assuming it's non-constant. So and it's a continuous function. So image should be an interval.
Yes.
Now the catch is, so if I have an irrational number, then correspondingly I should have a rational number also with gap of alpha, right?
Yes.
But we have uncountably many irrational numbers.
Yeah, we do not have that for every irrational.
No, we do not have that for every rational.
Yeah, I mean, for every irrational, we do not have a rational.
Yeah, exactly. Yes.
Yeah, that pretty much solved the problem, but I think I had something else, but it just slipped out of my head. Okay, that actually do the sum. Can I get some simpler explanation? Okay, I'll keep it in my head and we'll continue moving forward. I'll keep doing it in the background. Okay, if I arrive there. So is that explanation clear? Which this which just get explained in front of you? Anyone? That for every this q complement element, we do not have a rational here, so that we can keep getting a constant every time. I think we can also talk about that f of x and f of x plus 1. Okay, so I get that f of x is equal to f of x plus 1 plus a constant number alpha. Okay. From here. Okay, and now I'm taking f of x to be rational, right?
Yes.
And now I have irrational plus irrational.
That can be a rational. We can't say anything.
Irrational plus irrational can be a rational.
Minus pi plus pi is 0.
Yeah, I mean minus pi plus pi is 0. So that the only conclusion is 0. No, we can have more
pi,
numbers.
pi
Like
and
we
pi
can have
minus 1.
we can have square root 3 minus square root 3 and something like this, and then get another irrational, right? Yeah, but this is actually fixed, so that will also, like, I think might give us something, because this number is fixed, right? So we can't keep changing this number according to this number.
Yes. Yeah.
Yes.
And
Yeah.
that is what is coming up in the interval problem.
Yes, exactly. Yeah. So this side is rational and this side is irrational. So they are equal. Oh, this side is need not to be irrational. Yeah. Okay, fine. All right. So that is only the fact we can consider right now. But I think from here I went somewhere. I'll explain it later if I catch there. Okay. Let me move to a little bit simpler problem now. This was again a problem in the same exam. If any of you want to try and explain to others. We have been given a polynomial of order to degree 2021, and then the question is about roots. It's a multi-correct question. For answer for this is that there is no such function. Okay, you cannot find any function. The answer is actually okay. The answer is actually for this question is singleton 0. Okay, like the exact 0. I think there is some problem in the pen. It's 0. Okay, there is no such function. You can't find. Anyone want to try this now? You have a polynomial, and then the question is about the root. It's always interesting to solve such problem and difficult to sometimes if you get stuck. B, exactly one real root. Okay. So we started like this. So first I used Newton's method of finding root, which is sign changing. You can use Descartes' rule too, the number of sign changes. But anyways, so let's call this px, and if I put 0 here, I can easily see that the p of 0 is equal to -1. That is fine, and because I'll just be left with this last one. And if I put p of 1, then I'll get it's a positive number, right? You can sum it up, and that's like whatever it is positive. That is, I can say for sure. Okay. So between 0 and 1, this polynomial changes sign, or this function changes sign. Okay, so like this, that if you look for the graph, at 0 it is -1. Okay, and at 1 it is becoming positive, so it must cross x-axis at least once because it's a continuous map. So there is 1 0 in between 0 and 1. Okay, so there is a positive root, but exactly 1 we can't say. So we use Descartes' rule of sign change to know that there is exactly 1 0. How do we do that? We look for the number of sign changes. Okay, so there is no sign change, there is no sign change, and we arrive here and there is no sign change. There is one sign change. That is the maximum number of positive roots you can have for this equation, the number of sign changes in the polynomial. So you can have at most one positive real root, and we have at least one positive real root because it changes the sign in the positive side. So exactly one real root. B option is fine. There is no problem with B. We look for the other solution now. Is it clear? Option B, at most one and at least one. Anyone? Yes. Okay. Now we look for the other answer. At most one. Yeah. We look for the sign changes. Okay. So it's positive here. It's positive here, and then all of them are positive, and we get just one sign change. That's at most positive roots. We can get number of sign changes in the polynomial. Now, if I look for the negative one, how many sign changes we can have? So in that case, what I do is I replace x with -x. Okay. So if I replace here -x here, I'll get negative here. I'll get positive here. I'll get negative here. So many sign changes, and I cannot say anything at all. So in the negative side, I cannot say anything that how many roots are there, whether there are any root or there can be at most some number, but it's a large number. So the Descartes rule for sign changes doesn't work here. So we look for something else. But I do not have to, because the question is somewhat easy comparatively. So we can discard option D, that no real root is positive. We have a positive root. Now between A and C, or none of them, we have to select. So we started solving it. We differentiated it and tried to see that how many times the derivative changes the sign. We used then another trick where we try to take out common and make pairs. Like from here, I take x to the power 2020 common, and I get x plus 1, and then from next on I I take common 2019, and again I get x plus 1, and like this I can take x plus 1 common, and then I get a polynomial, and something like this we tried. Okay. And even we differentiated it, and then we tried in the derivative that how in the negative side whether derivative changes sign or not, or something like that. And then we looked at the option. It says that exactly one real negative root. Okay, we can easily discard this. And how can we do that? Exactly one real negative root cannot be there. Why? Because if you have one negative real root, okay, and one positive real root, that means total two real roots, and polynomial is of odd degree. And real polynomial with odd degree, if alpha is a root, then the complex conjugate of alpha is also a root. So the number of complex roots will be even. But in this case, I'm getting two real and 2019 complex, which is impossible for a polynomial. So that option is also gone. And we are left with A. Fine. I hope it is fine. Anyone? So like the question became instantly easy after this conclusion we had. But if you do not look at the option, then it's a difficult question for you. Okay, so we get A and B. Let's move to the next one. Is it clear? I have used Descartes' rule of sign change, and I have used that the number of roots, complex roots, are even for a real polynomial. Okay. You can try this one. The question says that which of the following subsets of R?
So we will not have any negative roots, is it?
Yeah, we will not have any negative root. That we had to verify, but we did. But yeah, that's also a good process. Yeah, you have to somehow that all root will be positive. That is also a true option. Yes, good to point out that this polynomial will have no negative root. That is also there. And how do we verify that? The number of sign changes in the negative part is like a lot, like 2010 or something. So we cannot do that from there. And what else we tried is we tried to do this only, and we got to the conclusion that the root will be in between -1 or 0 if there is any. And then we proved that there will also be a root in this as well. So we verified this, but that was like a long process. But yeah, we had to verify this, but otherwise we can't go for option this, that all roots should be positive, because exactly one real root is negative. Discarding doesn't fix that there will be no other negative roots, right? Yeah, true. Okay, try this out. Okay, anyone would like to answer this? A. No. So if you look for the connected subsets of R, then the only connected subsets in R are intervals. That's very clear. Connected means interval, interval means connected in R. Okay, and so what subsets you can have in R which are so simply the question is that which of these are intervals. Okay, so we look for intervals. So the first one is directly given that it's Q complement. Is it an interval? No, so we do not select that. Now what about others? We look for other sets. Like if I look at option D or option B, B says that I have to select pen again. Just keep okay, fine. The option B says that we have x cube minus 1 greater equal to 0. Okay, and since x cube is 1 map, so I can do this. X cube is greater equal to 1. And if I look at the graph of x cube, I somewhat get this. This. Right. And x cube is equal to 1 at this point. Right. So I get just these all x. Right. In this side, your function is this line is y equal to 1. And this is your graph y equal to x cube. Okay, so this graph, stay below the line y equal to 1 when your x is exactly lying in this side. So the exact solution to this equation is that if you take from 1 to infinite, is it fine? Because you can't pick x from the negatives, it will remain negative. And if you pick between 0 to 1, then the cube will become less than 1. So you have to pick more than 1 or at least 1. So 1 to infinite are the solution. So this set is exactly 1 to infinite. Now the question is whether this is an interval or not. Okay. This is fine. Anyone? Anyone? Any confusion in option B? Anyone would like to point out? No. No. Okay. How about C? Anyone would like to solve C? Option C. So I have given x cube plus x plus 1 is greater or equal to 0. So I want this to be strictly positive. What are such x? So I have to find the domain in which this function is remain positive. Let's call it fx. I have f of x equal to x cube plus x plus 1. Okay, that's my function given. C, I'm doing C. Okay. And I have to figure out that the set where it remain positive is connected or not. So what I can simply do is I can check the derivative if it remains positive. So if I do derivative f dash x equal to, I get 3x square plus 1, which is strictly greater than 0 for all x belongs to R. And that simply implies that f is strictly increasing on R. Is it fine? That means once it become positive, it will remain positive. It won't come down again. It will remain positive. So once it crosses the x-axis, it will go upwards only. So wherever it crosses x-axis, it will remain positive. Now, is that an interval? Yes. I hope you are getting it. Because the derivative is positive, the graph of the function will be strictly increasing. Okay, now if you have an increasing function and you are taking inequality like this, then that will give you only, like once it become positive, it can't come back downwards. So it will remain on the positive side. and you will get, once it crosses from that point, let's call it some alpha to infinite, it will remain positive. Okay, and it will cross for sure, yes, because as x tends to infinite, it goes to infinite, and x tends to minus infinite, goes to minus infinite. It's a polynomial of odd degree. Okay, so this will also give you some interval. Now, what interval is that? I don't want to find out. You can proceed further. Okay, so this will also be an interval. So we can select option C. Let's look for D. X cube minus 2x plus 1. Okay, now can we look for this? Is this connected? Anyone would like to solve this option D for me? Anyone? Anyone? Harinarayana, would you like to?
I mean, we can look for the roots, and once you know the roots, it's pretty clear. But finding the roots of cubic equation.
Yeah, that will kind of solve our problem. No, because if we look for the root, and the very first thing I can see that the sum of the coefficient is 0, right? I have 1 here, I have -2 here, I have 1 here, so that means 1 is a root. Okay, so 1 is one of the root of this polynomial. What are the other roots that we can divide it and figure it out? And again, if I differentiate here, then I get 3x square minus 2. That's kind of changing sign. So the derivative changes sign. So we cannot use increasing rule here. So okay. So 1 is one of the root, and I have so something like this. My polynomial becomes 0 at 1. So and if I go to the left side of the 1, whether I get negative or positive. At 1 I get 0, at 0 I get 1, so that's positive. So at 0 it is positive here, right? But like, can it give 0 in between? So either it's coming from here or it is coming from here. Okay. At 0 it gives me 1, and yeah, it remains positive. Okay, so we have to look for the root. I have x cube minus 2x plus 1, and if I divide it by x minus 1, which is the factor here, I'll get the another factor. And can anyone figure out whether the rest of the root are real, or is there no other real root here? Anyone?
So roots are real.
All roots are real.
Yes, so one is negative
Uh-huh.
and another is positive.
Okay, all right. So we get here 3 roots. Okay, so something as x tends to minus infinite, it goes to minus infinite. So it will, let's call this alpha 1, alpha 2, alpha 3. These are the 3 roots. Okay, and as x tends to minus infinite, it goes to minus infinite. So we'll come from here. It will go up, it will go down, it will go up, and then as x tends to infinite, it goes to infinite. So it will go like this. Now we need positiveness, so we get this interval and this interval. So union of 2 intervals, right? In this part function remain positive, and in this part function remain positive. So you have to factorize it. That is the only way. I'm just little lazy for that. So you guys can go ahead and find these alpha 1, alpha 2, alpha 3. I hope that the concept is clear. So this will also be good. To be precise, you will get alpha 1, alpha 2, which are 2 roots, union alpha 3 to infinite, and since you are taking less equal, so you will take closed intervals. Okay. All right. Let us move to the next question. I'll see if we can get to some linear or some algebra. Okay, just give me a second. Okay. I listed some more good question from analysis. Yeah. Let's see if we get here. Yeah, this is good question. Let's get some question from algebra, and then we'll come back here. And this, yeah, you can try this out. G be a finite abelian group of odd order, and consider these two statements. First, the map from G to G, f of G, Z square, is a group isomorphism, and the product of all element in a group is identity. Two statement. Anyone?
Yeah, both true.
Both are true. Okay. Okay. Anyone else feel otherwise? Would you like to explain?
Yeah, X and X inverse, G and G inverse will be pairs.
Yes.
So product will be identity because you have a odd number of things. So irrespective of abelian or not, it will be.
Yeah. Sure. Yes. That is for sure.
G to G square, assume it is, I mean, we just have to say that it is 1-1 map, right? G goes to G square.
Yeah.
If it is not 1-1, it means, yeah, you get the point, right? Because it's an odd order, so
Yeah.
you can't have two to go to the same thing.
Yeah, exactly. So I'll just give a little fine language. We have f from G to G, and f of G is equal to G square, and the question says it's an isomorphism. And now the first question arises that whether it is a homomorphism or not. Okay. So if you know, if you don't know, I'll give you the result. That if you take f from a group to group, or yeah, group to group, and you map f of x to x square. Okay, and you want this to be a homomorphism, then we want what? We want that f of xy is equal to xy whole square, and I want that f of x and f of y, this to be this only, right? So I get x square and y square. So I want xy square is equal to x square y square. This I want for this to be a homomorphism. Okay, now if the group is abelian, that's pretty much clear. But if group is non-abelian, then I can't say this. If I solve this further, I get xy multiplied by xy. I get x, and y. Okay. I operate y inverse from the right, and same here. I operate x inverse from the left, and same here. I get yx equal to xy. So that means the group must be abelian. So the very first result we get from here, irrespective of what question says, that for this to be homomorphism, you need your group to be abelian. Otherwise, this will not remain a homomorphism. Okay, so you can just note it down as a result. So I'll give you this, that f from G to G, f of x equal to x square is homomorphism or group homomorphism if and only if G is abelian. Right? Otherwise, it will not be a homomorphism because xy equal to yx we are getting, or we can just write it if and only if xy is equal to yx, or we can write that xy square equal to x square y square. So that means this result is true if and only if group is abelian for all xy. Or the other result could be that if xy whole square equal to x square y square for all xy belongs to Z, implies Z is abelian. And converse is very true, because if abelian, then we can do that. So a group is abelian if and only if xy square is x square y square. So that's kind of a condition for a group to be abelian. Now let's go back to the problem. It says that f from G to G and f of G is equal to G square is a group isomorphism. We have given abelian, so it's an homomorphism, there is no problem. We want to look for the isomorphism. Okay. So what I in case of homomorphism, a very good property is that you can easily claim 1 if the kernel contains one element. Now, what is a kernel? Kernel is collection of all those elements which are mapped to the identity element under the group homomorphism. Okay. So what is the kernel of a homomorphism? Kernel F is equal to all those elements G belongs to G such that the image of those G is identity, right? So in this case, what I want is I want G belongs to Z such that f of G is what? G square. So G square equal to identity. That means this simply implies that order of G divides 2, right? Because G square is identity. Now group is of odd order. Can there be any element of order 2? No. Lagrange's? There cannot be any element of odd order. So this simply implies that G must be identity because of the odd order. Otherwise, any element of order 2 would have been mapped to Z, identity only. So we get the kernel to be all those elements whose order is 2 or the element is identity. So that whole subgroup. Okay, so we get that the kernel here is singleton. Now, if the kernel is singleton, we can easily imply that the map is 1-1. How do we do that? Like, why if the kernel is singleton, then map is 1-1? The homomorphism is M to 1 mapping. Same for linear transformation. And same for ring homomorphism. It's M to 1 mapping. And what is M here? The number of element in the kernel. If your kernel has M element, then this is your group and this is your range. The packet of M element will go to one element. Another packet of M element will go to another element. Another packet of M element will go to another element. So it's an M to 1 mapping. The group homomorphism or homomorphism, like packet of kernel and then their cosets, they go to one element each. Okay. So anyway, so the kernel is trivial and hence the map should be 1-1. So the homomorphism is 1-1, and since it is from G to G and finite group we are taking, it's onto as well. So 1-1 onto homomorphism, isomorphism done. Okay. Now if you take any group and take product of all any finite group and you take the product of all the element of the group, then you somewhat you get like this. So in this case you have a group of odd order. So you have A and you have A inverse there. Right? Every element has its inverse in the group. Okay, and you have another element B, then you have to operate B inverse. You have another element C, then you have also have C inverse. And since the group is abelian, even if you do not write it in this order, you can make use the commutative property and make these all into this pattern. So if you take a finite abelian group, then you can somewhat write them like this, and then this is identity, this is identity, this is identity, and the product of all the element you get. So the element cancels out with their inverses and gives you identity as a product. So you get identity only. So these both statements are true. I hope it is clear, everyone. Anyone, if you want to ask any doubt, any question. Anyone?
The important point in second part is that we cannot have an element as its own inverse. That's the only problem.
No, what I'm saying is that if we have the element as its own inverse, then we will not operate it over there. Yeah. So the odd is also there. And how about the group being abelian? Can we do that in non-abelian?
In non-abelian, this expression doesn't make sense in the first place. So.
Exactly. So the abelian also is there, and then the element of order 2 is not there. That is also a fact. So those two property together, getting used here. Okay. All right. Let's move to the next question again from the analysis. This one, function of two variable, you can call it, or multivariable calculus as some calls it. So you have been given a function from R2, from a subset of R2 to R. Okay. And then it's x sine 1 by y, and then the question is whether it is discontinuous on this given D or continuous, or whether it can be extended to be a continuous function and something like that. So yeah, anyone would like to try? You can answer in the comment, or you can explain yourself if you want to. D can be extended. Okay. Anyone else would like to explain this question? So, okay. So the function is x sine 1 upon y. Okay. And at 0, 0, the function is not defined. We can't define this function as 0, 0 because we are getting 0 sine 1 upon 0. That's not defined. And they are not defining it explicitly at 0, 0 as well. Okay. So if we look at the function, what is the domain here? The domain here is this one.
Sir, actually, we can't see the C and D last parts. Your head is blocking the.
Okay. Yeah, you could just tell me that earlier. I hope it works fine now.
Yes.
Yeah, great. Okay. So we have been given the domain as this. So the whole R2 is there, but from R2 we are taking out this x, the whole x-axis, and yeah, including 0, right? So this x-axis is out. This is not in the domain. Okay.
Okay, and now I would say C.
Yeah, exactly. So we do not have the x-axis in the domain. And if I look at the function x sine 1 upon y, okay, so I can see that if you take any non-zero number, like x is non-zero and y is non-zero, then the function has no problem, right? Because sine 1 upon y is a continuous function whenever y is non-zero. X is also a continuous function whenever x is like whenever you, whatever x you take. So x sine 1 upon y has no problem at all, except at 0, 0, right? Only problem is when y becomes 0. If y is 0, then we have a problem, right? And y is 0 and only at here or on the x-axis. Okay. Now, okay. So the option 1 says that f is a discontinuous function on D. But we have removed already these points. Like the D doesn't contain this y equal to 0 line. This is y equal to 0 only. So y is non-zero. Then this function has no problem. So the function is actually continuous. Okay. So f is actually continuous function on this D. F is continuous function on D and cannot be extended continuously to any point outside D. So anyone wants to explain this? It cannot be extended to any other point outside D. Anyone? Can we extend this function outside D? Like, can I talk about this point to a continuous function I want to extend? So how does extension works? If I want to extend a function to a continuous function, what things I need there? I need that the function should have limit at that point, so that I can put limit equal to value. If function does not have limit at that point, then I don't think I can extend it, right? Because I need limit at that point. If the function doesn't have limit, then I cannot extend. Like I cannot extend 1 upon x. I cannot do anything such that I can make it continuous at 0 by redefining it at 0 or anything, because it doesn't have limit at 0. So I want that at least I get the limit at that point. So now anyone that this function, whether it can or cannot be extended?
So it cannot be extended.
It cannot be extended. Outside D we can't extend it. It seems like we can't. Let me just try this. So because whenever I take y to be 0, I can't have the limit, can I?
You can extend it to 0, 0, but
At 0, 0, do I
Okay.
have limit? Yes, I have limit at 0, 0. Right? So I can extend it at 0, 0, right? Because all I have to do is I just have to check the limit at all the points. Okay. So let's see. Let's try to check the limit for this function. Okay. So I have f of x equal to f of xy is equal to, I'm like very habit of one variables, x sine 1 upon y. Okay. And I have to check limit at the point where y is, x, y. And so let's consider this to be 0 only, 0, and x belongs to R at these points, precisely on the x-axis. Okay. Now, if I take y to be 0 and x to be non-zero, so let's consider x equal to some like t. It's a non-zero point, constant fixed t. Okay. If I do this, so I get t times sine 1 upon h, limit h tends to 0, something like this. And we do know that this thing does not have limit at 0. So no limit. Okay. So the moment I take x to be non-zero, this function will not give you limit at all. We can use some other techniques to show that the limit doesn't exist whenever your this x is non-zero. But what happens when we take x to be 0 as well? So now what I want is, I want that x comma y to be 0, 0. I want to check limit at 0, 0. So how do I do that? So I'll use the technique sequential criteria. Okay. So if you remember, if you don't remember, either way, I'll give you a small definition here in case you don't remember. Limit x tends to alpha, you can extend it in the same manner to the two variable. F of x exists if and only if for all xn converging to alpha, f of xn must converge to some number, let's say it is equal to L, must converge to L. Limit at a point exists if and only if you take any sequence in your domain which is converging to that point alpha, the sequence must be from the domain alpha, the image of that sequence must converge to L only, which is the limit. Okay. So in this case, let's consider this sequence. Let's take alpha n equal to a sequence xn and yn which is converging to 0, 0. Now I'll check f of alpha n. If that converges every time to a fixed point, I'm taking an arbitrary sequence, not a fixed sequence. So I'm proving for all the sequence. F of alpha n is equal to xn. Yes, anyone? Sine 1 upon yn. I have to find limit n tend to infinity here. So this xn goes to 0. Okay. And this sine 1 upon yn, because sine function is bounded. So where do you think the product will go? One sequence is bounded, the other sequence goes to 0, the product goes where?
0.
So the limit exists and equal to 0. So at 0, 0 limit exists. So we can redefine this function f of x, y equal to this when your y is non-zero, and 0 when x and y both 0, 0. Now at 0 limit equal to value, and hence function is continuous. Done? Fine, I hope so. Yeah, so at other point it doesn't give you limit, because that sequence xn will not go to 0 anymore. Here we are using this going to 0, helping this sequence. But if this doesn't go to 0, then this is just bounded. It gives you all the limit point between -1 and 1 when yn goes to 0. So the set of all limit point for this sequence is -1 to 1, all of it. That can be proved. Okay. All right. Let me move to this question, and then I think we are almost running on the clock. This question is from the linear algebra, and it's a decent question, but we can modify it and make a better question out of it. Try this out. It says that let M and R be the real vector space of n cross n matrices over with real entries, and n is at least 2. And to consider a subspace W which is spanned by identity A square and so on, then the dimension of this W should be like, what can you say about the dimension? Anyone? This is also a good question from linear algebra. The paper was like of level. IISc made a paper. Okay, like I usually go for NetJRF, and I don't find such deep conceptual question in NetJRF paper from IIT JAM. Yeah. At most 10. Okay. So how do we do this? You have been given that M and R be the real vector space of n cross n matrices with n is at least 2. Okay, and you have picked a matrix A belongs to M and R. So now we have fixed the matrix A. So we have a matrix A belongs to M and R. Okay, and the concept behind this question is actually, if I take the characteristic polynomial of A, that will be something like this: x to the power n plus a n minus 1, x to the power n minus 1, and so on, plus a naught. A monic polynomial of degree n. That's the characteristic polynomial. And I know that if I put a inside it, a, I get a to the power n plus a n minus 1, a to the power n minus 1, so on, plus a naught identity, then every matrix satisfies characteristic polynomial and I get 0 matrix. Right? That means if I take a set S which contains a to the power n, a to the power n minus 1, and so on, a and identity matrix, and I choose coefficients to be 1, a n minus 1, so on, a1 and a naught, then with respect to these coefficients, if I take the linear combination, I get 0. And all of these are not 0 because 1 is non-zero. So if you use the definition of Li and Ld, what can you say? That S is Ld, because we have a linear combination of the elements or vectors of vector from the set S, such that their non-trivial combination, not all coefficients 0, but linear combination is getting 0. Right? So this S is a subset of M and R, and S is Ld. Right? How many elements are there in S? Anyone? How many elements are there?
n plus 1.
N plus 1 element. If you take n plus n1 element, you are getting an Ld set. So to make this set Li, you should throw out at least one element. at least one element. So if you want this S to be Li, then you should throw at least one. So if I take cardinality of S to be n plus 1, then it's LD. So to make it Li, you should throw at least one. If you throw one, then it may be Li. We cannot guarantee that it will be Li. Right? Because if I take A to be identity matrix, then I take identity again. All of them are identity now. And your n is maybe 2023. Okay. So we cannot give guarantee that the dimension will be n or will be n plus 1, but we can give guarantee that if you want to take an Li subset of this set, if you want T contained in S and T is Li, then cardinality of T is never exceeding n. Okay, that means number of linearly independent vectors in this set can be at most n. Now, if you look at this set, these are the elements only, because the next powers a to the power n plus 1 you can generate from a to the power n and these elements. The next power you can keep generating using the characteristic polynomial. So they are already LD. If you exceed n, the rest of them are already dependent on these powers. So we are concerned about these n plus 1 powers. Okay, now my question changes that even with the n element it can be LD. So what will be the exact dimension? Can we say anything about that? What will be the exact dimension of this vector space, which is spanned by identity A and so on, a to the power n? What will be the exact dimension? So if I go to the next step, I look for so I want to pick some element from here, and I want that the linear combination of them becomes 0. Okay, I know one fact though, that if I take MAX to be the minimal polynomial of A, then I do know that MAA is going to be 0 matrix. Yes, MAA is going to be 0 matrix, and also that if for any polynomial, if P of A equal to 0, then MA divides P. If the minimal polynomial is the smallest degree polynomial such that the matrix satisfy that polynomial. If any other polynomial satisfy the any other polynomial such that the matrix satisfy that polynomial, then minimal will divide that. Okay, so the minimal is exactly the degree. Okay, so if your minimal polynomial is have degree d, then you will have d plus 1 coefficients. Now you cannot get 0 on d this less than d plus 1, because if you do, then the minimal has less degree. So the exact dimension will be the degree of minimal. Is it clear somewhat what I'm trying to say? Anyone? Or should I explain it in another manner?
So please repeat the minimal part.
Yeah, sure. Okay, so so far, so now what we have is that if you have a matrix A and A be some matrix of n cross n, okay, and you take some set S, and you in the set S you take identity A square and so on, a to the power n, and keep going like this. Then one guarantee is there that if you take W is equal to the linear span of S, then we are sure that the dimension of W is never exceeding n. Why is that? Because of the characteristic polynomial, right? So that becomes the first result, and that's all our problem. Now what I'm saying is that will it be exactly n, or can it be less? That is an interesting question. Okay, now what I'm saying is that if you have a minimal polynomial of this matrix, again the characteristic is of degree n, the minimal is of degree maybe n or maybe less. Okay, so if I take minimal polynomial of A, and let's say that is a naught plus a1 x plus so on plus a d minus 1 x to the power d minus 1 plus x to the power d. That's again a monic polynomial. Okay, this, let's say this is the minimal polynomial. Right, then I have MAA is equal to A naught plus A1A plus so on plus A d minus 1, A to the power d minus 1 plus A to the power d is equal to 0. This implies that if I take a set, this is identity here. So I have identity A square and so on, A to the power d is LD. So even this has less than n element, maybe less than n. Let's consider the minimal has degree less than n. It can be at most exactly the characteristic. Otherwise, it is of less degree. So let's say in the extinct case that that it is equal, then in that case I'll get the same n here. If it is less, if the minimal polynomial is degree less than n, then this set is also LD, right? And the rest of the power you can generate using these d only. A square A to the power d. You can use these and generate the other powers as well, up to n or even like as many as you want. So what does that give you? That gives you that the dimension of W is less equal to, and so I have d plus 1 element here, right? So if I want this to be Li, then I have to throw out 1 at least again. So the dimension of W is less equal to d. And what is d? D is equal to the degree of the minimal polynomial. Okay, now my question again is, can it be less? Can it be less than the minimal polynomial? Let's say it is. Okay, let I have some r less than d, and I have A naught plus A1 x plus so on plus A1A plus so on plus A1 sorry A okay, A naught I, let's call it A naught I, A1A plus A1 A to the power r equal to 0. That means that I'm getting A square up till A to the power r, I'm getting an LD set. Let us assume. Okay, so this implies that this is a small, this is a polynomial. If I take Px equal to with these coefficient only, this is another polynomial such that the matrix satisfies this polynomial, and the polynomial has degree less than minimal polynomial. Isn't that the contradiction to the definition of minimal polynomial? The minimal polynomial is the smallest degree polynomial which such that the matrix satisfies that polynomial, right? Or annihilates. But if you are saying that you are getting LD in the less, that means the minimal polynomial is less degree. Or there is another polynomial which has degree less than the degree of minimal polynomial, and yet matrix satisfies that. That's a contradiction to the definition of minimal polynomial. So we cannot have that. Thus, it cannot be less than D, and it will be at most D. So that concludes to what? That the dimension of this W will be exactly the dimension of its degree of its minimal polynomial. Okay, so the second result will be that dimension of this W is equal to degree of minimal polynomial. Minimal polynomial of A. I hope it is clear now that the exact dimension of this will be the degree of the minimal polynomial of this matrix A. Now, whatever matrix A is given, you can find the minimal and you can claim that, okay, this will be the dimension. That can be like another question in future. Fine. Yeah. Okay. So I think we are kind of exceeded the time. I had some more questions, but let's say we'll do those in some other session. Yeah. So that will be all from my side in this session, sir. Are you there?
Yes. Okay, thank you. Thank you, Rajendra, for this nice session.
Yeah.
Especially the tips that you have, your insights about the JAM examination that you have shared will be really useful, I'm sure.
Yeah.
Now it is time for feedback, dear students. If you have anything to ask, any queries that can be asked, or you can share the feedback about the session.
Good evening, sir.
Yeah, Shikha.
I am Shikha, and I've completed my integrated MSc from Birla Institute of Technology, Mishra, and I'm from Jharkhand. So today your session was really wonderful. The question was really good, and we get to know a lot of new concepts. So it was really nice. I'm so hoping more such sessions from your side. Thank you,
Yeah.
sir. So one more thing that I would like to ask that I'm preparing for GATE now. So could you please give some tips for GATE also?
Yeah. Gate. Yeah, sure. We can have some session on gate as well in future. I think for the gate, the distribution is very different from the CSIR net. So I hope that you already you were preparing for the CSIR net exam. Mostly, I'm assuming that. Yeah. So yeah. So the syllabus is same, but almost same. But the difference is between marks distribution. Now we have equal marks for the ordinary differential equation and partial differential equation, and these also even more marks like OD and PD, two subject alone are around 20 or 22 marks in the GATE exam. So that's 20%, more than 20% of the exam. But whereas in the net exam, they are just like 30 or 35 marks combined together. So the mark distribution is different. So now you have to work on more subjects. And I would suggest you to go through some topic of LPP or optimization technique. Those will help you. And for that you can consider some NPTEL lecture. I forgot the name. So you can watch some NPTEL's lecture on OR. Those will be helpful for you for GATE exam only, because the GATE exam is made by IIT's faculty only, and they have been teaching on LPTEL. So they try to construct a question from that theory mostly. So I think those courses will be somewhat helpful for you.
Yes. Thank you, sir. Thank you a lot. Thank you, Vinod, sir.
Okay, thank you, Shikha. Others?
I am Dharmendra Singh.
Yes.
I am audible.
Yes, Dharmendra.
Yeah. I am Dharmendra Singh from Kasganj, UP. I am preparing for IIT JAM also, and I want to ask about some reference books and some tips for NBHM also. And I want to ask about your research experience and what is your topic and how to decide topic. I read somewhere in foreign university they demand some research paper. How can we write a research paper before PhD also?
Yeah, like those were a line of a question, but I'll try to answer some of them. So yeah, so if you're preparing for JAM, I think you should take it step by step. Okay, so your very first step should be trying to get good marks into this IIT JAM exam and get into a good university. Okay. Once you get into the good university, you will mostly like IITs, if I say, they do this project thing in their final semester. So you will get to do a project under some professor. Okay. And that project is kind of a research, like somewhat research. You try to explore a topic, and then on that topic you give presentation, and so that's like your research exploration in your masters. And on the basis of that, you write a proposal to the foreign universities professor. So they help you in that. And if you can find out some professor which can take you like this, so that is one way to get into foreign university for PhD. So again, it starts with clearing IIT JAM and getting to a university. So that's the first step.
Yes, sir. Yes, sir. Thank you, sir.
Yeah, you're welcome.
Thank you, Dharmendra.
Yeah.
Any others? Yes.
Hi, sir.
Yes,
I'm
Shyama.
Shyama Kumar. I'm a BSc Maths student at Aspirants University. Sir, it was a wonderful session. It was very helpful. Thank you so much, sir.
Yeah, you're welcome, Shyama.
Thank you, Shyama. Yeah.
Hello, sir.
Yes, Praveen.
Sir, I am Praveen
Hello,
from
Praveen.
Kerala. Thank you for the interactive session. Sir, I would like to ask one more thing. The JAM or any other competitive exam, they are different from our university exams, right? So, should our motive be completing the syllabus, or will picking certain topics be sufficient for scoring well?
So you are talking about IIT JAM exam, right, or university exam?
For IIT JAM, sir.
Yeah, for IIT JAM, I think if you look at the questions that we have done right now, and you can easily see that they are asking conceptually strong question, like with the greater intensity from some previous year papers. There is scope for both. That if you go for particular topics and you go for formulas, there are some marks that you can score from there. And but again, that if you want to be in top like 300 and even top 100, if that is your goal, then I think you will have to go for both. You will have to go for formulas which you need to recall, and you will have to go for concepts so that you can score better as well. Because the formula, I think, is like, I think the majority of the population can do formula, and they can work on formula, and then they can go for the exam, and they can do all those questions which you can do. So if you want to get ahead of them in the line, then you will have to go for concepts as well. So if you are looking for a good rank, pretty good rank, then you will have to go for both. If you're looking for qualifications, then I think even formulas will get you that. I hope that clarify your doubt, Praveen.
Yes, sir. Thank you.
Yeah, you're welcome.
Okay, thank you, Praveen. Others?
Sir, my name is Muhammad Naeem. Actually, I am doing BSc Maths as a distance mode. Is there any problem for that? MSc graduation IITs?
Distance mode, I don't think that there is a problem. I think there is an eligibility criteria, but I haven't been through that. If sir know anything about that, I am not so sure.
Yeah, there is no such discrimination between whether you are doing the course like in a regular mode or distance mode. The only thing is that you have to qualify the JAM examination with a good rank, and you should score at least some 60% or something like that marks in your qualifying examination. That means degree examination.
Thank you, sir.
Yeah. Okay.
Yes,
Hi, sir.
Gopika.
Sir, my name is Gopika Sunil. I'm a second year student at St. Thomas College, Thrissur. I found today's session really useful. I'm currently preparing for my JAM examination. Thank you for the class. Thank you, Vinod sir, for organizing this class. Thank you.
Yeah, you're welcome.
Gopika. If any of you would like to share a feedback, please do it now. Okay. So I think we may wind up now. Once again, thank you, Rajendra, for this nice session.
Yeah.
So I hope to arrange more sessions with you in future, especially for GATE examination. I think it will be really helpful for many students. And
Yes.
and I would again I am very expressing my thanks to you and wishing you all success in your research career. Thank you, Rajendra.
Yeah, thank you so much, sir. And everyone, you should all be thankful to the sir. He's putting a lot of effort for all of you. So, yeah, he's kind of like send me a reminder. Okay, this is you. Are you ready for the class? You should be ready. Okay, so he's putting that much effort, and it's all for you. So you should guys all be thankful to him, and thank you, sir, for doing this for all the students.
Okay, thank you, Rajendra, for your nice words. Thank you. So thank you, everyone. Let us wind up here.